Everyone, my name is Elliot Battles, and this is my submission for the Cloud Computing Specialization for Coursera. This is task one. So I just want to briefly run through some of the steps I took and some of the things that I did in order to accomplish this. So I'll move quickly because there's a lot of information. I don't have a lot of time, but essentially what I started with was the on-time data set. It's covered here in yearly files. Each yearly file had a number of zip files in it that contain CSV files for each month. Several files. So what I initially did was created a simple Python script that took a subset of the data and combined it into yearly files. This data was then stored into S3. You can see here all my 21 yearly files, each one about 400 to 600 meg, about 400 to 500,000 rows each. Storing in S3 was an advantage because I could stand up, tear down clusters, not have to worry about losing my data, and S3 is cost efficient compared to storing the data in EC2. Once I had that, I was then started standing up my Hadoop clusters. I used EMR for this, Elastic MapReduce, and I could use S3 disk CP, so S3 distributed copy, to actually load my data into HDFS each time. And so then running it in HDFS allowed me to quickly iterate across it, and my MapReduce jobs ran quicker. And I could tear down the cluster when I was done and pull it back up. It only took a few minutes to load in the data, so that was helpful. I didn't have to leave a cluster running the whole time. And so what I did most of my work in Hive, and so once the data was in there, and you can see here's all my data. It's a very large set. It's about 9.8 gigs of data. I could then run my different MapReduce jobs. I again through Hive to answer the question. So for group one, the initial question is just ranking the airports by total to and from traffic. So that was a simple matter of just taking how many times that airport was the origin, how many times that airport was the destination, combining those and getting a total, and then just spitting out the top 10 after I ordered them. So I did most of this on the command line, but I'm doing this in Hue because I think it's a little bit easier for video purposes. But you can see here this is an active cluster, and it's running the MapReduce jobs. I'm gonna make cuts to this video so I don't waste time. All right, so you can see the output, and it looks like Chicago is the busiest airport over this time period, and you've got the logs of all the mappers and reducers that ran. The second question in this group was asking about ranking the carriers on their on-time arrival. For that question, I'm not going to actually execute the MapReduce job or the Hive query because of time, but I essentially looked at the arrival delay flag. So arrival delay after 15 minutes defines as a delay, and so I just calculate as a percentage. Because it's ones and zeros, I could add them up and divide by the total count to get a percentage of how many flights were delayed for each carrier, and then spit out the top 10. The second group of questions asked, initially to rank each airport by the top 10 carriers in on-time departure performance, and then also subsequently each destination airport. So either carrier or destination airport were the two questions that I answered. And so looking at it, I answered them very similarly. Looking at it from a carrier perspective, I took advantage of the rank function within Hive. So I ranked based on the origin. I calculated the percentage similar as before, adding and dividing by the count, get performance, and then rank that across each origin. And then I wrote it into this carrier rank table. And so after the MapReduce jobs ran, I had basically, the origin and each carrier and its associated departure on-time performance, and then the rank associated with that. And that allowed me to, just focus on the top 10. The airport, the destination airports, it was very similar query. I just changed it from ranking the carrier to the destination, and so everything else is essentially the same, and the output is the same, where you have the origin and this destination, and how often it from that airport to this airport it departs on time and its associated rank. And then the last question in that group was asking source to destination pairs, and then essentially asking if to rank each destination pair, the carrier that flies between them, their arrival on time performance. And so, again, looking at using the rank function for each origin and destination pair, ranking them, and then I've got the output here, the origin, the destination, the carrier, its departure performance, and the rank associated with that. And so that way I could get the top 10 for each one of these. I had them in these structured Hive tables. I did some slight manipulation in Pig to get it more into a key value store, and so then I stored that into S3, which then allowed me to load it into DynamoDB, which I used instead of Cassandra. So I've got my airport rank here. You can see the airport, and then all the associated ranks, and so I can query from here. So I can pull up CMI, and there's CMI with all its destination airports and the rankings associated with them. That number is the rank, and then the destination. Same thing with the carriers. The source destination, again, I stored the key as source and destination pairs, and then so then I can query this based off that. So CMI to Chicago. There's one carrier that operates that route, apparently. Rank. And finally, the last question was looking at a series of to, from, date, and looking at the minimum delay, and there were some constraints around time of day and when to leave for the second leg. And so in order to accomplish this, I loaded all my this is only 2008, all the 2008 data with the delay. What I did was I broke up the flights into two tables. Flights that left before noon, flights that left after, and then I could then do a join with that information. I joined those two data sets, and I did it, where the destination was equal to the origin, and since I knew all of them all the origins were leaving before noon and all the destinations were leaving after noon by joining these two data sets, that helped me with the first constraint. And then I could add in the the piece that he was leaving 2 days later, and so then I've got all my data set there between going to and from and the appropriate dates all joined into one data set, and then I could rank along the total delay. So then again, I manipulated in Pig to get it into key value, where the key is to, from, final destination, and the date it originally left. And so you can see here, this is in Hive, but I then stored it into DynamoDB, and which I can then query against. And so that is essentially how I solved this task and the steps I took. Thank you for your consideration, and hope to look at some of the other videos that are being posted. Thank you.